I am Reshma Roy Chaudhary, faculty in the Computer Science and Engineering Department of HIT, and your moderator for the evening. Artificial intelligence is being used for a variety of fields like workflow management tools, trend prediction, education, and space exploration, maybe to name just a few. Artificial intelligence, as we know, can collect and organize large amounts of information to make insights and guesses that are beyond the human capabilities of manual processing. Its potential is such that it is honestly hard to picture our future without AI. Our esteemed speakers today will introduce you to the evolution of AI and the promises it holds for the future. Dear Mr. Prateep Sen and Professor Prosenjit Gupta, we are delighted to have you as our speakers today. Our first speaker today is Professor Prosenjit Gupta, professor at Heritage Institute of Technology, Kolkata. Professor Gupta has 25 years of experience in academia and industry. He received his PhD in computer science from the University of Minnesota. That he received his B.Tech and M.Tech degrees in computer science and engineering, both from IIT Kharagpur. In the last 25 years, he has held various positions in academia and industry, including postdoctoral fellow at Max Planck Institute for Informatics, Germany, professor at International Institute of Information Technology, Hyderabad, architect at Yahoo, Bangalore, dean at NIIT University, Neemrana, Rajasthan, MTS at Bell Laboratories at Murray Hill, USA, member of consulting staff at Cadence Design Systems, San Jose, USA, senior lead engineer at Mentor Graphics, Hyderabad, and professor at Heritage Institute of Technology, Kolkata. He has over 85 publications in various international journals and conference proceedings. He is a senior member of ACM. He is also the founder of Ilahe Technologies, Kolkata, a startup in the area of software training and consultancy services. Dear Professor Gupta, the webinar begins now. Over to you.
Okay, thanks for the introduction. So let me just share the slide. The topic of today's webinar is artificial intelligence, its evolution and the future promises. So I'll first speak on the evolution of AI as a discipline, and subsequently Mr. Prateep Sen will take us through the future promises it holds. So over the years, artificial intelligence has emerged from the research labs as a mainstream tool, and almost all aspects of how we work and how we live today, from retail to manufacturing to healthcare, have become increasingly digitized. And we wish to exploit this digital data from people and things to automate and assist in what we do today, as well as find out new ways of doing things that we have not envisaged before. So this increased data is resulting in automation and the personalization of products and services. And this is where AI comes in, expect to be the key source of this transformation, disruption, and competitive advantage in today's fast-changing world. And the impact is ubiquitous, spanning several sectors: healthcare, automotive, financial services, transportation, logistics, entertainment, retail, energy, manufacturing, and you name it. So the economic impact is tremendous, and there are productivity gains from businesses automating processes, robotic process automations, or RPA as we call it, been deployed in by IT service providers on a large scale, and it's poised to eliminate the manual effort associated with many regular tasks and business processes. There are productivity gains from businesses augmenting their existing labor force with AI technologies, and there are software robots which can do low-level routine tasks 24/7, which is beyond the human capacity. And these also increase consumer demand, resulting from the availability of personalized and higher quality AI-enhanced products and services. And recommender systems, as we call them, are ubiquitous today in recommending personalized advertisements, news, products on the web. And all of us are using these kind of services on a day-to-day basis. Now, where did all these things start? AI research, as we know it, started in the 1950s, trying to answer some basic questions like, can computers think? And subsequently, research focused on automating intellectual tasks which were being performed by humans. A lot of these efforts tried to create handcrafted rules. And but then a chess program with lots of rules did not involve any learning. But a lot of people at that time, 1950s and 60s, believed that computers could achieve human level intelligence by handcrafting a sufficiently large set of sophisticated rules. So this was the thinking of, so I have not tried to define AI, so as we progress, we'll see how people have actually tried to address this question of what is AI and then how it has evolved. So initially it was thought to be a rule-based approach to solving problems, and people thought that computers could achieve human level intelligence by simply using lots of complicated handcrafted rules. And so this was called symbolic AI, and this was the dominant paradigm from 1950s to 80s, and peaked with expert systems work, research work, and in the laboratories as well as in the industry. And expert systems often involved a large set of sophisticated handcrafted rules. And then the challenge came as follows. It was increasingly difficult to enumerate the rules to tackle very complex problems. And people wondered if we could automate the process of the rules creation as well. And this is where AI inched towards what we know as the machine learning today. If we step back in time, one more century, Charles Babbage designed the analytical engine in the 1980s, 1830-40 period. And although this was never fully implemented, it was the first design of what we understand as a general purpose computer, and used mechanical operations to automate computations. But even those days, people had doubts, and people started thinking in terms of what machines could really achieve. And in 1843, Ada Lovelace, the computer scientist, remarked about the analytical engine of Charles Babbage. The analytical engine has no pretensions, so I'm quoting verbatim. Analytical engine has no pretensions whatsoever to originate anything. It can do whatever we know how to order it to perform. Its province is to assist us in making available what we are already acquainted with. So the idea was that it can do whatever we know how to do, and we can tell it how to do. Right. So that people were wondering whether this could actually lead to something which could solve problems which humans could not. But then I think very early on, computer scientists understood that there were limitations. And so then another landmark thing that came in this idea of thinking about what is AI and how developing the early ideas about AI was Alan Turing's work, who introduced the Turing test in his seminal 1950 paper called Computing Machinery and Intelligence. And he pondered on whether a general purpose computer could learn and be capable of originality, and he postulated they could. So now, what is this Turing test? The Turing test is basically goes in very simple words, something like this. So suppose you have a AI program, and you try to see if people can interact with it, and they can understand that they are not interacting with a human but with a program. Can they differentiate? So if you succeed in fooling people into believing that they are really interacting with people, and they cannot distinguish that between the interaction with people and the interaction with the program, and then that program has passed the Turing test. So a lot of expert systems research in the 1960s, 70s actually aimed at developing systems which could pass the Turing test. So machine learning evolved from all this in attempts to make computers do things, whatever we know how to order it to perform, and learn how to perform a task. Instead of programmers listing out the rules, the goal was to have computers learn the rules themselves from the data. Right? So this was the first departure from the traditional way of rule-based systems that happened. So in very simple words, classical programming computes the mapping of rules, mapping from rules and data to results. So you give a set of rules, And you have a data and then you map it to results. So this is classical programming. So we write a program which is basically writing down those rules in some language, programming language, and then given some input data, it produces results. So machine learning computes the mapping results and data map to rules. So meaning that from results and data, it creates the rules. To be more precise, we first compute from results and some example training data, we compute a set of rules. And then given the rules and given some input data, you compute the results. So this was the departure in the paradigm of how we moved on from the traditional rule-based systems to machine learning. So this started flourishing in the 1990s and soon became a highly popular subfield of AI. It was fueled by better hardware and bigger available data sets. And machine learning is technically searching for useful representations of some input data with a predefined set of, in a predefined space of possibilities using guidance from some feedback signal. And the simple idea helps solving a broad range of tasks in speech recognitions to autonomous car driving and has lots of applications. Now, today we have been hearing a lot about what we call deep learning. So this is a subfield of machine learning. And the goal here is to learn representations from data. And this is learned by learning successive layers of increasingly meaningful representations. And the deep in deep learning stands for this idea of successive layers of representation. So how many layers contribute to a model of the data is called the depth of the model. And modern deep learning often involves tens or even hundreds of these successive layers of representation. Right? And all the layers are learned automatically from the exposure to the training data. So in deep learning, these layered representations are learned via what are called neural networks. And these are structured like layers stacked on top of one another. And the input to target mapping is done via deep sequence of simple data transformations. So this is a picture of a neural network. So you have an input layer. So these are pieces of information. And then they are mapped to another set of layers and another set of layers and so on. And so what is deep about deep learning is this number of layers. Okay, so this number of layers actually goes into tens and hundreds and so on. And what is the learning involved here? So there are weights on these edges that you see, and there are functions at these nodes. So the learning involves actually these learning the weights on these edges. So in very simple terms, that is what is neural network is all about. And then deep learning actually has tried to do a lot of research in trying to find out what would be the good structure of this network and what is how many layers are required and how many layers will be useful and what will be the functions at these different nodes and so on. So there is a whole body of work that has been going on and has been successfully applied to lots of very challenging problem solving over the years. So the specification of a layer, what a layer does to its input data is stored in the layer's weights. So as I was saying, these edges that you saw in the picture, they have weights, and these weights are what is actually learned in the learning process. So this transformation is implemented by a layer. This is parameterized by these weights. So in this context, learning means finding a set of values for the weights of all the layers, such that the network will correctly map the example inputs to the associated target. Okay? So the learning involves learning the weights, as I said, across all these layers. So a deep neural network can contain tens of millions of parameters. Finding the correct value for all of them is a challenging task. And modifying the value of one parameter will affect the behavior of all the others. So fairly complex problem. So this is what it looks like. So you have layers and weights, and then there are predictions, and then there are targets, and there are loss functions computing the departure of these predictions from the targets. And then based on optimizer, you try to reassign the weights, and then you try to feed it back to the network, and then redo the computations and so on. And then, of course, there are various different kinds of algorithms for doing all these things. So just to take a pause here, so we saw the traditional traditional programming paradigm was to take rules and data and map it to the output, right? The result. And then in machine learning came along, and then there was the training data and the rules, and then so the training data, and you had to map it to the rules, and then the rules was being used on the input data to map it to results, right? So essentially, a machine learning solution involved the training data as well as the rules creation engine. So there was some computation being done. So you have to say how the rules are to be created, and then of course you have the training data. So it was the data plus the computation, and then with the deep learning coming along, you have the data, and then you have the algorithmic computation, and also you have the network. Okay? So the design of the solution involves actually there are three things there. So you have the training data, then you have the algorithm for the learning, and you also have the structure of the network. So in very short term, so has been the paradigm shift. So initially we were looking at the traditional programming flow and then just trying to create lots of rules, and then we moved on to machine learning where we try to learn the rules. And here in deep learning, we have to provide a learning algorithm as well as we have to provide a structure of the network, and then we try to learn the weights. So developments in the last decade has been very eventful in the world of AI. So I just take you through a few bullet points of what happened. In 2011, Dan Sirison of the IDSIA, Switzerland, began to win certain academic image classification competitions with GPU-trained deep neural networks. And this was the first practical success of modern deep learning. And 2012, Jeffrey Hinton and Alex Kizepsi of the University of Toronto participated in the ImageNet competition. And this was an yearly large-scale image classification challenge. And the ImageNet challenge was notoriously difficult at that time. It involved classifying high-resolution color images into 1,000 different categories. And the ImageNet training was done on 1.4 million images. And in 2011, the top 5 accuracy of the winning model based on classical approaches in computer vision was around less than 75%, 74.3%. And this Toronto team was able to improve this accuracy to 83.6% using deep learning techniques. And since 2012, ImageNet has dominated the deep learning based algorithms. And 2015, the winner reached 96.4% accuracy in the space of 4 years. So what was actually unachievable or thought to be unachievable over long number of years, suddenly in a space of 3-4 years, actually everything really changed. And this had a tremendous impact on other fields as well. A lot of people sat up, took notice, and then decided to try and apply these techniques in other domains. ImageNet classification problem is considered to be well solved today. And success of deep learning is attributed to automation of the feature engineering phase of machine learning. So what led to this development of deep learning post 2010? Major reason has been hardware. CPUs have become increasingly faster by a factor of 5,000 plus between the 2 decades, between 1990 and 2010. And from 2000 onwards, NVIDIA and AMD have put in major thrust in development of GPUs, which were massively parallel hardware suitable for games. So these were originally a lot of specialized hardware being developed for the gaming industry. And in 2007, NVIDIA launched CUDA, a programming interface for its GPUs, making their power accessible to many parallelizable applications. So Google has introduced TPUs or tensor processing units, which were developed for running deep learning applications, and these are faster than best GPUs for certain types of computations. So a lot of developments have been taken place in the hardware side, which have contributed this part in deep learning research and the success therein. The availability of huge data sets has also been of great help for the developing AI applications, and algorithmic improvements have made training of deep learning networks feasible. And funding for AI related projects have also substantially increased across the world as a result. So also there have been a lot of developments of frameworks like TensorFlow and PyTorch, and the rise of user-friendly libraries like Keras, which make deep learning easy. And full potential of deep learning is believed to have not reached yet. But there has been a lot of active development over the last decade, as we saw in these bullet points, and then there is also a lot of work going on even now. Some diverse application where deep learning has had success huge progress in the last decade, revolution in areas perceived difficult in ML, near human level image classification, near human level speech recognition, handwriting transcription, machine translation, question answering. These are some areas where deep learning has had a deep impact. So another area where there is a lot of interest in the application of AI and particularly deep learning techniques today is natural language processing. So NLP is focused in developing systems that allow computers to communicate with people using everyday language. And again, here also there has been a paradigm shift in the 1970s, 80s, syntactic approaches based on context-free grammars. These were actually more popular. And then slowly they got replaced with statistical methods. As more data became available, it was easier to deploy such methods. And it has also benefited from recent progress in deep learning. So natural language processing, in this we look at a lot of different problems like spam detection, part of speech tagging, like what part of speech was noun, verb, and so on. So these are useful for downstream NLP applications. Named entity recognition, so you see a sentence, there are a lot of words, so which is the name of a person, which is the name of a place, and whether there is a verb, there is a word out there which is naming a company and so on. So these kind of entity recognition or a place, and so that's called NER or named entity recognition. So there are so these are certain problems which are well solved, and then there are problems on which a lot of very good progress made. Sentiment analysis, looking at a movie review in text and then understanding whether it's a positive or a negative review. So e-commerce sites benefit from reviews on their products. Co-reference resolution, so you have a long sentence and then you refer to something at the back of the sentence, right? So you said uh, X and Y did this, then he said something. So he is referring to X or Y. So from the context, we can make out, but then developing systems where you can automate such processes remains a challenge. Word sense disambiguation, there are many words which multiple meanings, and which particular meaning is pertinent in that context, that is called word sense disambiguation problem. Machine translation means translating from one language to another. And then there are problems which are considered challenging even today, and a lot of very active work going on today in the NLP domain. Question answering, so this has deep applications in a lot of areas. Text summarization, so you have a paragraph and then you actually summarize it. So you see this in, for example, if you go to a news portal, like so you'll have big news item and then it is summarized into a headline which is of one sentence, right? So these things are today done automatically. So there are also like lots of applications in development of dialogue agents and chatbots, and we see applications everywhere, and all these have benefited from advanced AI techniques. So one of the key problems with natural language is the ambiguity, and this must be disambiguated. So for example, you say a sentence like this: I saw a man on the hill with a telescope. Now, are you talking of the man with a telescope, or is the man standing on a hill with a telescope? So where is the telescope? Is it on the hill, or is it with the man, or is it I am having the telescope, right? So these are kind of disambiguities we have naturally built into the language. Ambiguity is useful for efficient computation, communication. Say, for example, during this talk, I can refer to this talk. In this talk, we will say this. In this talk, we'll do this, and so on. So you know which talk I'm talking about. So I don't need to say every time that in this talk scheduled today on the 1st of June on this topic, I am saying this. So I don't need to elaborate on which talk I'm referring to, or when I'm talking about, say, I'm maybe teaching a subject and I'm actually in the middle of the lecture and then referring to a particular topic in the textbook. I don't need to mention the whole name of the textbook because my audience understands which book it is. So ambiguity is very useful for efficient communication, but then when you are actually trying to implement automatic systems, it becomes very important to resolve these ambiguities, and this is where the challenge comes in. It is ubiquitous in NLP, it occurs in speech processing, syntactic analysis, semantic analysis, everywhere, and then there are lots of these disambiguation techniques which come into play. So some interesting applications today: travel reservation chatbots, automatic speech recognition in cars, video search by capturing words in the soundtrack, cross-language information retrieval, translation, grading subjective type answers in so this has been deployed in automatic grading of papers and so on, answer papers in exams. So this was an overview of how AI has evolved as a subject as a discipline over the last few decades. And here are some references. And if there are additional questions, you can send them to my email ID. And thank you.
Thank you for the wonderful insights, Professor Gupta. I would request the audience to hold the questions for now. I would suggest that you keep your questions typed in and ready. So we'll take the questions at the end after our second speaker. So our next speaker is Mr. Prateep Sen. Prateep brings 25 years of experience in sales management, distribution, product management, and marketing in leadership roles across industries like banking, FMCG, technology, and insurance, and across geographies like India, USA, and UK. His experience is in launching new and large initiatives from inception with emphasis on creating robust processes distributed through a complex multi-geography sales structure. Prateep has worked at Titan Industries, Citibank, and JP Morgan Chase. Since 2013, Prateep has co-founded and launched 2 startups in Kolkata. Tribeca Care is the first one, an elder care and home care company, and Curafoot, the second one, a podiatric care solution company. So Curafoot has developed an AI-powered food diagnostics and product recommendation platform targeted at hospitals, clinics, and footwear. Prateep holds a B.Tech from IIT BHU, a PGDBM from XLRI Jamshedpur, and an MBA from Columbia Business School, New York. Over to you, Mr. Sen.
Thank you for the very kind words and the introduction. It's always difficult to speak after someone like Professor Gupta has spoken. But what I try to do is to give you the business point of view so that you understand what is it that you can do with AI, right? So many of you, because you're in college right now, you will get into AI and you will be a practitioner and actually creating the algorithms which will make all of this possible. But many of you will actually not do that, but actually see what is possible and then see how you can utilize that. So what I'm going to do over the next, maybe about 20 minutes is to sort of walk you through, I as a person who is a business person, how do I see about using this technology? So fundamentally, let's start with one of the first things that people talk about, which is the utopian view or the dystopian view. And in that, the question is that will AI rule over humans? And as everyone says, very unlikely. So Matrix, the movie, will just remain, all of that will just remain in the movie and nothing else. So moving on from that, right? Will AI be the solution to everything, including human progress? To a large extent, yes. The reason is what they say is, and we'll talk about that, is that AI, what it's doing is what the Industrial Revolution did about 200 to 300 years back, in which they brought mechanization into factories. And suddenly that is the way that productivity increased of people. And as a result, what happened was that the prosperity of people went up. Similarly, what people are now saying, the next one that happened was actually electricity, which happened about 110 years back or 100 years back. And that actually increased productivity by another set of values. Maybe about 40 years back is when computers came in. And right now what people are saying is that AI is going to be the new electricity. So we will see a lot of upheaval, a lot of changes, productivity increases, and it's going to increase or it's going to improve the lives of most people. At the same time, what's going to happen is that there will be a social repercussion, right? So government, what will happen is a lot of jobs, right? When Professor Gupta says that, and that's the Turing theory, that AI is trying to take on what a human does. So if a human can figure out what a dog is a dog and a cat is a cat, right? And over a period of time, it can figure out whether a tumor is a tumor or not. It can actually start replacing a lot of people. And that is one thing that will happen. So yes, there will be a repercussion, but in the long run, what people again talk about is that it's going to become better. So again, if I have to quote something, not likely, and I'll read it out, not likely that near-term AI systems will autonomously choose to inflict harm on people. It will be possible for people to use AI-based systems for harmful as well as helpful purposes, right? So it's in our hands about how we use it. So moving on from this, very quickly, and as I said, as a business person, let's see if I can. So do you see the next screen? I'm sure you do. So where does that take us, right? So AI is expected to, as they say, ripple into every part of our lives. And very simple examples is that menial things that we would find it difficult to do, or stuff that we find, very onerous, is going to be immediately taken on by AI. Right. So for one example is the email spam filter that all of us are used to. Right. About 6-7 years back, 10 years back, you would see a lot of these Nigerian prince wanting to move money, and they wanted you to put in some money and so on. All of those spams will sort of move away. You don't see it anymore. Sorting cucumbers in Japan, and a lot of you would have actually seen that. That's actually there as a TensorFlow Google example. One of those first examples that everyone quotes is that there was this Google guy who went back to his farm in Japan, and his mother used to actually spend nearly a few hours segregating the good cucumbers from the bad cucumbers. And he actually got this algorithm and the TensorFlow, the whole thing in place, through which the machine was able to do what his mother had to do over a few hours, right? So very repetitive work is happening, right? Another very good example is, and we'll come to other examples, auto suggest on WhatsApp. You write something on WhatsApp and it almost tells you, and it fairly does a good job in Hindi and Bengali too, about what's the right word you're trying to choose when you're trying to communicate with someone. So broadly, as I said, artificial intelligence is the new electricity. And let's talk about where does this actually, in which domains does it impact us? What I'm not trying to do is a lot of things that, the first few pages, the next few pages, I'm not going to go over it with, in a lot of detail, because what I'm telling you is what you can also read out, right? I think what I'm going to talk about is where am I using AI, right? And that's towards the end, we'll have that. But when it comes to actually transportation, and I'll just go over the domains where this is there. So when why does transportation need AI? And very simply, what you have is that you bring together a lot of things that has happened over the last 10 years. So data has increased, connectivity has increased, sensors and cameras, it's there, all come together, and suddenly you have total changes in the transportation industry. Very simple example is Uber. As soon as the mobile phone came in, Uber came about. But where is Uber going to take this industry is the question, right? And Tesla is another good example. And how is this whole thing changing is that it started about 20 years back when you had small little gadgets coming in. I still remember when I was in the US about 20 years back, GPS was there. It was very slow. So by the time I would take the chain, by the time they told me what to do, I would have gone past that crossing, right? But it was the first gizmos that sort of came into the cars. But now over the next so many years, what has happened is you have a lot of other things that have come into a car that you're driving yourself. Right, so the blind spot, you have now a camera which can tell you what's happening in your blind spot. So these are the things that happened over the last, about 20 years. You add to that the GPUs that that NVIDIA has and all of these guys have, and suddenly the smart car that you have is become autonomous. So a person is actually, you don't need a person driving it. You will, you'll have the car driving itself. Repercussion of that again is that transportation planning will change, because now people may not be wanting to buy cars. They may be just using Ubers or driverless cars. It's going to be cheaper. You may not have that many parking spots, problems, because no one is really parking their car in front of, Esplanade or something. And suddenly you have a totally different world happening just because AI has come in and all these gizmos have come in, right? This will also actually create a lot of new and next generation vehicles. And we'll have to see how that actually results, Moving on, right? And healthcare and elder care is where I'm going to spend a little more time, right? So, but very simply, I don't know how many of you have actually followed. One of the top contenders on the healthcare side of a medicine, of a molecule that they think is going to help is when they put all the data into an AI model, and then the AI model was able to actually very quickly come up with a much curtailed, bunch of molecules that they will do testing on to figure out whether it's going to work for COVID, right? And the clinical use is something even I'll talk about when I talk about Curafoot. But just on the, what AI will try to do is what a doctor does. A doctor will ask questions, and in his mind, he's trying to figure out what's happening. And then AI can actually ask the same questions and can do the same algos on the back of it, right? Healthcare analytics is, again, taking population data, taking data from a lot of different people, putting them together and then saying that, if I, Prateep Sen, are diabetic, how will my disease progress and what should I do, right? So I sort of put myself into cohorts and then as a cohort sort of look at it. And that's another place where AI can actually help a lot. Healthcare robotics is where you can have, surgeries being done by, an AI-led robotic machine. Another area where I think there's something called Da Vinci, which is trying to do that in the US. And obviously, when you bring all of the mobile health, right? So you'll have lots of Fitbits and ECG pacemakers all together coming in, and that should be very quickly be able to tell you who was the who would actually need to go to a doctor and who wouldn't need to go to a doctor immediately. So those are the things that are happening on the healthcare space. Elder care, and I will talk about that in detail, so let me not talk about it, but very quickly, life quality and independence, right? You have elderly people at home. How do you make sure that their quality of life is good, right? And the question is, you think of elder care and quality of life, and all you can think about is ayahs and nurses. And how does that whole thing, and how does machine language sort of work within that is critical. And it could be as simple as being able to nudge, the son of an elderly person in Kolkata, nudge the son saying that, why don't you give your mother a call, right? AI should be able to figure out when was the last call made to the mother, and therefore about time he makes a call, and that will probably reduce on things like depression and all of that for the elderly person, right? So through this process, what will happen is treatment and devices will again change. So you can have a lot of IoT devices, wellness devices that can come about. Small things like having a sensor under the bed, making sure how many times has she flushed to know that, whether there is, she needs to drink more water. Very small things like that can actually come together with AI on the back of it. Education, I won't again get into this in a lot of detail, and I think colleges such as Heritage will be sort of thinking about all of these things. But how do you actually teaching robots is fairly many years out, but personalization at scale, right? How do you yet do the same teaching, but you're teaching every kid, every student at a different pace? Right? How does that work? And that is where ML can actually, and in China, they're doing a lot of these, in classes, you have cameras in which they can actually see when are the kids yawning, right? And depending on that, they will know that which segment of what the teacher is teaching is very, very, boring, let's say, right? And that is when some intervention needs to happen. So learning analytics, understanding how to do it, facial recognition, all of that is happening actually in China. And finally, the mothers of China love it because now they know exactly what's happening to the kids in the class. Let's not get into privacy and all of that. I'm sure it has those problems, but you can still use it in a certain way. So public safety, again, this one again has very huge privacy issues. But cameras for surveillance, or even this what's that app that we have for COVID, right? It can actually help us. A lot of people will say, "Oh my God, the government is now going to see what I'm doing at every moment." But when you look at it otherwise, it can actually help us a lot, right? So public safety, drones to figure out what's happening, drones checking on COVID places and where the congregation of people are happening, cybersecurity, all of that becomes very critical. And why you need AI is that you can't have people reviewing their cameras all the time. You should be able to have AI which is actually monitoring all of that and then being able to say, these are the problem areas and therefore what you need to do. Entertainment, very quickly, Netflix, again, I don't need to talk about this, but Netflix will tell you what sort of movies that you like to watch, right? Facebook, TikTok does the same thing, a lot. Uh, Social media, you would know exactly who your friends are, and YouTube is another example, what sort of stuff that you would want to watch. There's another issue on the back of it is that you keep on getting funneled into one thing, one sort of thing to watch, but then it's the plus and minus that you have to sort of weigh against. Finance, I won't get into it, is huge again, but credit history based on social media and mobile usage, right? So if I am speaking to uh, Professor Gupta, and Professor Gupta has a good credit history, they can actually say that maybe even I do too, right? So how do you take all that data and try to sort of make sense out of so much of data and then decide who am I going to give a loan to? These are the things, again, that's happening through AI. With that, what I'll do is I will dive into one of the companies that I co-founded, and I'll probably spend the next few minutes just talking about that. So I don't know how many of you know about Tribeca Care, but it is Kolkata's largest senior care platform. And I'll just, so what do you mean by senior care? Senior care is, the senior population, the 60 plus population. We think that there are 10 lakh seniors in West Bengal, of which Kolkata has about 4 lakh out here. Seniors, when we look at seniors, it is not homogeneous. It's not the same, same thing for everyone. People are very different. The 62-year-old is very different from the 72-year-old, who is different from the 82 or the 92, right? So very, very different needs are there. People are different. It's again a segment that is growing at about 20%, right? So 1 out of 6 will become elderly or senior in about 10 years' time, right? 1 out of 6. Right now, it is 1 out of 10. Issues that they have, and I won't go through this, but they have physical problems, loneliness, security problems, social engagement, reduced immunity, and we know what's happening, due to COVID as a result, and a lot of time on the hands. You take this information and you see something that Tribeca would have done, right? 20,000 seniors, 100, 2,000, seniors in certain events that we have done, 60 lakhs hours of medical care that we have provided, 5,000 emergency hospitalization. We are managing a lot of the senior facilities. When you take all of that and then think about senior care as an industry, you realize that it is not a simple industry, right? So you have on one side, you have caregivers like the IRs and all that. Then you have doctors and clinicians. You have hospitals to deal with. You have people at home, and we sort of manage thousands of people in their homes. We have assisted living facilities. And then you think about it and then say that how can AI help? And where does AI even come about? Fundamentally, where it comes about, and going on, is that when you're providing a solution like this, yes, you're providing 24/7 emergencies, you're providing care managers and post-hospitalization care, and you have so many people in so many different homes, which are not in a hospital setting, but in actually 1,000 homes around, or maybe 2,000 homes around Calcutta, right? And then you say that how am I going to monitor what's happening in each one of those places, right? And how do I get the data in, and how do I really focus on the places where I need to monitor? And that is where something like AI comes in, right? So you have devices, you have SOS devices, you have anti-fall risk solutions that we have, right? You bring all of that together, get all the data to sit in one place, and then you start feeding that data into an AI engine who can then tell you that the at-risk patient are these 50 or these 100. And that is where our effort will go for that day. So, taking an example of that, in the US, there is a suicide helpline in which they fed all the, and it's a chat helpline that they have. And they figured out that one of the biggest reasons, the AI was able to do what a human could not do. They figured out that there are certain words, if a person uses, that person is on a higher risk level for suicide. And we would have thought, a human would have thought that it would be things like, I'm not feeling good, or I am feeling depressed, or, looking for, a rope, or, I don't know, certain things, right? What they actually figured out is that paracetamol and Tylenol, which is another medicine like paracetamol, is if a person says that they're looking for that, it's, there is a much higher chance of that person wanting to commit suicide. And that is something that a human did not know, but actually the AI engine could actually figure out with the training data that they had given. Moving on, in a Tribeca case situation, sort of we spoke about this, but all the data, the senior safe or the home, the home safety sensors, as I said, right? How do I get a camera which will say how many times has the elderly lady gone to the kitchen or to the bathroom, and then using that data, instead of a person looking in all the time, just using that sensor data, be able to then say, she is at risk. She is at risk for a fall, looking at gait analysis data. So all of that data can actually help on the senior side. What I'll then do is, and I'm just looking at how am I doing for time, I'll just go a little faster. So Curafoot is another company that we have. And again, on foot, what you would say that why would we need AI? Very quickly, you have a lot of people with foot problems, you don't really know where to go, right? And so this is a good slide to actually say that. So if you have a foot problem, you first need to diagnose what the problem is, and then you have to get solutions to do that, right? So you need to say, what do I need to do if there is a problem? How do you do a diagnostics on the foot, right? How many podiatrists are there? In the US, there are lots of podiatrists. In India, you really don't have that many foot doctors. You go maybe to a GP, maybe you'll go to a Bata, and you'll say, Paya bata ache ami ki kori, and they will tell you, ei juto tak pore ni, or something like that, right? But just to understand that, is there a much smarter way to do that? And what we have done is we have brought in a kiosk which does, and you can see that little, and this is actually there in certain Bata stores around the country, is that a person stands on it. It does a 3D scan of the foot. Using that 3D scan, and that's that's the picture of the 3D scan. It actually tells you, it shows the feet, the shape of the feet, right? Whether you have a low arch, high arch, all of that is something that the AI engine can actually pull out. So, the left-hand side is where the clinical for diagnostics is. So that is where the actual scan happens. It could happen through a mobile phone. It could happen through a 3D, much bigger scanner, which is placed on the floor. That data goes into an AI engine. That AI engine does two things. Number one, it does a foot condition detection. So it can actually tell you that you have plantar fasciitis or you have a heel pain or whatever it is. And on the back of it, it can actually recommend a product. So now what you think about it, right? You don't need that many doctors. You don't need that many podiatrists. Just by doing a scan with an AI engine and a bunch of questions, you can decide you can figure out what has happened to that person. And then based on that, you can actually do state-of-the-art manufacturing, and we use 3D printers and 3D milling machines to actually design the footwear that person needs to have. So this is another example of what we've given to Bata, right? So once the person comes in, you can actually then, and these are actual products that you can sell just based on the AI engine or the rules engine, which is, right now it's rules, but certain parts of it is moving into AI, based on which you can determine what is happening. So go back, right? And this is actually the end of what I was going to talk about. When you take this whole thing in context, you will realize that something as small as a foot problem will get so much just out of AI and ML, right? So is it going to touch our world? Yes, it is. You wouldn't know where, right? So for an elderly person, who is with Tribeca, she knows that there's an ayah who's helping on her, but she does not know that there's a person who is AI trying to figure out who to actually go to. And a lot of the AI that you'll see is going to be not in the face, right? You will see it working somewhere. It's going to be impacting your lives, but you would not know where. And I think what's going to happen is you'll get so used to it, you would not even think that AI is touching you. With all of this, that's going to happen is that the entire, I think the world, the way that we operate is going to change. And it's people like you who will have to think about how will you bring about that change, because the next 20 years is going to be totally tumultuous, right? So it's going to be actually, the upheaval will be fairly large. And all of you will have to think very, very, a lot of you are getting into new jobs. Think about which are the jobs that you want to go into. Is going to be repeatable, and therefore those are the jobs which will move away into an AI engine? Or do you want to get into jobs in which you'll have to sort of think a lot more? And what they're saying is that anything that is repeatable is what AI is going to do. But if you want to be a professor, if you want to be a thinking person or a creator or an entrepreneur, those are the jobs which will always be there, right? So with that, I think this is my background. With that, I just want to say thank you. I think we have a few minutes for questions, and we can then, I'll hand it over to Professor Rashmi.
Thank you so much. It was really to get such a detailed insight into how you're using AI in your startups. While I was going through your bio, I was wondering how, so I now have a better vision of that. So we are open for questions now. And while we wait for other questions to come in, we already have two. So Abhigyan Prakash Jha from Heritage Institute of Technology has asked, can we get help or assistance for deep learning projects? And how can we connect with companies for career orientation if we have skill in machine learning and deep learning domain?
I think what's happening is, even when we started, and I'm actually, Professor Gupta is a consultant, working with us also. We've always been we always wanted to get people who would come in and it should be a symbiotic relationship in which we can actually, we have the data, we need people who can actually come in and sort of, build the models, think through a lot of the problems. So we would always like to have people like you out there. So please reach out to me, please reach out to the professor, we can try to figure out things. But I think more broadly, the question is that there needs to be a way to actually get a lot of you into industry. And I think there is a role that people like me and other companies have in actually going out to the colleges, to the people, and then saying that these are the projects that we have. Are there people who would want to do that? I think that is one of the things that is a takeaway from me, and I'll try to do that a lot more, at least with the people I know. Professor Gupta?
Yeah, just to add, I think few heritage students are already expressed interest to me to work on some AI projects with Curafoot and Tribeca, and so we are talking to them, and they are undergoing some training right now. And so definitely, if there are other people interested, they could talk to us.
Thank you. So we'll move on to the next question. Sumit Raj from Heritage Institute of Technology has asked, and this is a question for Mr. Prateep Sen, what is the future of AI with humans?
I'm sorry, with what?
What is the future of AI with humans? That is his question.
This is a question, and it's the same question that happened many years back when they said that machines are coming, right? Industrial revolution, what's going to happen to humans, right? If machines are going to do that. The same thing happened when, computers came, and, all the bank people were very scared that their jobs are going to go away because machines are coming. Fundamentally, nothing's going to change. You'll have totally different jobs coming up, right? The jobs that will happen in a post-AI world is going to be very different from the pre-AI world. So there will be a bunch of humans who will be without jobs, and it'll be very difficult to actually retool them because they don't have the skill set. Maybe they're older. All of that's going to happen, and I think society and government have a role to play to actually figure out how to help those people. But when you look at the overall set of people, right? When I look at the world more broadly, I think humans will be better off because you will have lesser people doing menial job, but you'll have more people doing much better jobs, right? So even in elder care or as a doctor, the doctor will not have to ask that many questions to do his diagnostic. He may have the AI helping him along, and he may be actually doing really the high-end stuff wherever he's required. The productivity is going to increase a lot more for people. I hope that answers your question.
Okay, I have if any of you do this, given this pandemic soon going to be in a post-pandemic situation, we have seen how being online, or rather relying on machines even more, has paid off, or we are going to rely on machines even more in the future. So, firstly, my question is, what are the fields that you think AI is going to play a greater role given the current situation? This is one. And the second is, both of you have wonderful experience in startups. So, for lesser mortals like us, if anybody is interested in startups, what would be your 2 words on how can they arrive at an idea? How can they think that idea is a feasible one to go ahead with?
Very good. So so 2 questions, right? So the first question is, where will, in the post-pandemic world, actually I can't say post-pandemic because the pandemic is still around, but in this world, in the new world, which are the industries which will really boom as a result of it? I think where AI is concerned, the trajectory is so big, it does not really matter about which industry you're talking about. Yes, we will have the airlines industry and the hotel industry, which is slightly down right now, but I'm sure in about 2 years' time, things are going to pick up, right? So let's not really think about, is it going to impact me right now or later? But you'll see that there will be a lot of changes when it comes about in terms of connected devices. I think people are a lot more thinking about how they are working at home and have a job, and they have their kids and their parents, and so that connection that will happen, the connected devices, the connectivity, those are things which will be very, very crucial right now. But where AI is going to play a role, I think, is in everything, right? So with the TCS saying that they're going to get 100% persons working from home in 2 or 3 years, you think about how they're going to do it, right? It's going to be not people who will be sitting down in rooms trying to do menial stuff. There'll be a lot more AI on the back of it, and there'll be managers who are going to manage it, right? So for a lot of you who are early 20s thinking about what to do, right? Read up about a lot about this, right? It's just not about me, but there's so much data around this in the industry. Read as much as you can, and then figure out what you'd want to do. Like I said, there is no industry where you're not going to have AI, right? The second part of the question is, how do you come up with ideas, right? And as an entrepreneur, and I'll just spend 2 minutes on this. Fundamentally, it's your idea does not come in itself, right? You're not going to be like Newton sitting under a tree and that apple of the idea is going to fall on your head. That is not good. I think how ideas come about is when you talk to tons of people, when you're reading a lot, when you've worked in different industries, when you're a generalist, right? When you've seen so many different industries at some point, right? And you don't know where the idea is going to come from. It can come from your Uber driver, it can come from your professor, it can come from someone like me, but you just have to be curious, you just have to be talking, you have to read a lot. And when those ideas, when you've read enough, spoken to enough number of people, looked at real problems, and that is where I would ask all of you, do not try, my personal recommendation is, do not try to be a specialist, where people say that that is the way to go. Try to work in different departments. So even if you're in IT, try to work in sales, try to work on the product management side, and suddenly you'll see problems that people are facing, and then you'll start thinking of solutions, and that's how it's going to happen. It will not happen because you will just one idea is just going to bombard in your head one fine day. Thanks.
I think we have time for 2 more questions. Professor Gupta, there's a very interesting question that I want to place to you. Alokparna Devnath has asked, collaboration of AI with human life may lead to existence of cyborgs, very common in the near future. But won't such an advent affect the natural human species?
Yeah, well, I think it's still, the question is still open. I mean, no one has answered to how things will really evolve. But I always believe that, at that humans will still rule. The reason is that, when you are talking of, I was talking of these programming paradigms. People started creating rules. Then they started thinking how to make the rules be created automatically by the computer. But then someone had to write a meta rule to create those rules which would be created by the computer. And likewise, when you are saying deep learning can do everything, then there is a human at the top, designing the deep learning solution. So the level of abstraction at which human beings operate in solving problems will increase. It goes into higher levels of abstraction. And say a few hundred years from now, people will be solving problems which we don't know of today. And they will not be solving the problems that we are doing today. Maybe many of them will be automated and will be solved by machines, but they will need to solve a higher level abstraction of problems. That's my thought on that.
I'll answer that also.
Mr. Sen, please.
No, it's an interesting question, and I just love to give my inputs on that, right? Fundamentally, if you look at what we have done, right, you have a mobile phone and you have all the gizmos that we have right now. And if I put myself back 1,000 years, and a person of that time, the biggest king of that time looks at me with my phone and my fancy gun on the other hand, I will be a cyborg to him, right? It's the same person, same flesh and blood, but it is, right? So now the cyborg is only where the mobile phone now gets, as a chip into my ears or something like that, and I can get some VR through that process. Yes, that's a cyborg, but I think it will still be humans, but that human and machine, even we are interacting so much with machines today, that's going to be absolutely ubiquitous. And I think even to some extent, we are part cyborg right now. So you're not going to have a separate species coming to kill you. I think we will be that species itself. Anyway.
I think fair enough. So I guess we can conclude the question answer session with this. Thank you, Mr. Sen. An announcement for the attendees: you're going to receive your e-certificate soon. Also, I just received an update that Principal Sir's net connection is not okay. So I would like to conclude the session. I would like to thank the speakers once more for taking out time from your schedule and giving it to us. This was the first webinar from Heritage Institute of Technology. Thank you all for making it a success.